Alright, today we're going to be talking about section 3-2, which is proving lines parallel. So last time we were given the information that the lines were parallel, and then we proved that two angles were congruent, that different angle pairs are either congruent or supplementary. But now we're going to be given that information and we're going to be asked to prove that the lines are parallel. So the first postulate that you need is the converse of the corresponding angles postulate. And that says that if two lines in a transversal form corresponding angles that are congruent, then the two lines are parallel. So last time we learned that if two lines are parallel, then the corresponding angles are congruent. So now we're just going backwards. So let's go ahead and try an example of this. So we have our two lines, A and B, in our transversal, which I've labeled C, and we're looking for corresponding angles. So let's put angle 1 and angle 2. So this postulate says that if angle 1 is congruent to angle 2, then A and B are parallel. So again, last time we were given the information A and B are parallel, so 1 and 2 must be congruent, but now we're just going the other way. So it's pretty easy. If angle 1 and angle 2 are congruent, then A and B are parallel. So let's try another theorem, and that's the converse of the alternate interior angles theorem, and that says that if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. So let's take a look at an example of that one. So because we're looking for alternate interior angles, we're looking for angles that are on opposite sides of the transversal and that are in between A and B. So let's label this one angle 1 and let's label this angle 2. And so the theorem is actually going to read exactly the same, that if angle 1 is congruent to angle 2, then A and B are parallel. So same kind of idea, we just need to know which type of angles that we're looking for here. The third theorem that we're going to learn is that if two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. So the key here is that we're looking for supplementary, not congruent anymore. Remember that when we're looking with same side interior angles or same side exterior angles, they're going to be supplementary. They're not going to be equal to each other. And one of my students remembers this by saying same side supplementary. They all start with S, so they go together. So hopefully that'll help. But let's take a look at an example of this one. So with same side interior angles, we're looking for angles that are on the same side of the transversal and again in between A and B. So angle 1 and angle 2 would be same side interior angles, and it's pretty simple to look at this and see that those two are going to be supplementary and not congruent. So if you do forget, you can just look at the angles and it's pretty obvious that those aren't going to be congruent. And so this one says if angle 1 plus angle 2 equals 180 degrees, let's say, then A and B are parallel. So, same kind of ideas as we've been talking about before. The next one is the converse of the alternate exterior angles theorem, and that says that if two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So, an example of this one, because we're looking for alternate exterior, looking at on alternate sides of the transversal, but outside of A and B. So, let's call this one angle 1, and we'll call this one angle 2. And so if angle 1 is congruent to angle 2, then A and B are parallel. Okay? And the last one that we're going to talk about today is called the converse of the same side exterior angles theorem. So that says if two lines in a transversal form same side exterior angles that are supplementary, hopefully you remembered that, same side supplementary, then the two lines are parallel. So let's look at that. We're looking on the same side of the transversal but outside of A and B. So let's put angle 1 here and angle 2 there. And so again, we're going to have if angle 1 plus angle 2 equals 180 degrees, then A and B are parallel. So again, we're just looking at the same types of examples that we've been using already. We're looking at the same angle pairs. We're just applying different knowledge. We're given different information. We're proving different things. So let's try to put some algebra in with these and use these that way. So if I told you that this angle was 40 degrees and that this angle was 2x plus 6 degrees, how would you solve for that? How would you solve for x? And the question would read, find the value of x so that A and B are parallel. And so because these are corresponding angles, we know that the value of x has to make this angle congruent to this one in order for A and B to be parallel. So we could set them equal to each other. We can have 2x plus 6 equals 40. And we can subtract 6 from each side and have 2x equals 34. And then we would just divide both sides by 2 to get x is equal to 17 degrees. Or I'm sorry, not 17. It would be equal to 17. So that then you could plug that into over here. So 2 times x, or 2 times 17, is 34. Plus 6 is 40. So those two are congruent. So we know that A and B are parallel. So hopefully that one makes sense. Try a couple more examples here. With this one, we have this angle is equal to 55 degrees, and this one is equal to x plus 25 degrees. And these are actually corresponding angles again. I didn't mean to do that. But they're corresponding angles again, and so they're going to be congruent if A and B need to be parallel. So we have x plus 25 equals 55. We just subtract 25 from each side, and x is equal to 30. Again, if you want to check your answer, you can go over here and plug it in. 30 plus 25 equals 55 degrees. So this angle and this angle are congruent, which would make A and B parallel. All right, let's try one more example here. Let's do one where we have alternate interior angles. So let's make this 95 degrees. It's obviously not drawn to scale, sorry about that. And we'll make this one 2x minus 5 degrees. So because they're alternate interior angles, they need to be congruent. So we would set them equal to each other. 2x minus 5 equals 95. We would add 5 to each side to get 2x equals 100. Divide by 2, and x is equal to 50. And if you want to check, you go back over here. 2 times 50 minus 5, that's 100 minus 5, which is 95. So that angle and that angle are congruent. So hopefully that helps. I beg of you to subscribe to my channel so that you get emails whenever I add a new video, and I'll try to do this once a week so that if you miss a class, you can just log on here and get what you missed. So I hope this helps, and thank you very much.